Let's first cover some basic spreadsheet terminology. When you open Excel, you have the option of creating a new blank workbook or opening an existing workbook. We're going to choose New and then Blank Workbook. Workbooks are the highest level component in Excel and are represented as a .xlsx file. So when you open an existing workbook or create a new workbook, you are in fact working with a .xlsx file. The workbook contains all your data, calculations, and functions, and contains several other underlying elements that make up a workbook. A workbook consists of one or more worksheets, each of which is represented by a tab in Excel. Each worksheet is given a name which is displayed on the corresponding tab for the worksheet. By default, each tab is named Sheet 1, then Sheet 2, and so on. To make these worksheet tabs more meaningful, it is usual to rename them so they make more sense in relation to the worksheet's purpose. For example, you might call a worksheet January Sales, or perhaps the name of a region or store, or even an office or department. To do this, right-click the tab and choose Rename. Instead of right-clicking to rename, you can also just double-click the name of a worksheet tab to rename it. Essentially, worksheet tabs can be named anything you want to fit your particular needs to make it easier to understand what that worksheet represents. Note that a worksheet that is highlighted as the Tire Sales Worksheet tab is here is referred to as the active worksheet. If you want to order your worksheets in a different way, that is very simple to do. Either drag a worksheet tab to the left or right and drop it in the place you want, which is represented by the little black arrow. Or if you are not comfortable with dragging and dropping, then the longer way of doing that is to right-click the worksheet tab, select Move or Copy, and then in the list titled Before Sheet, select where you want your worksheet tab to be placed and click OK. Every worksheet is made up of a lot of rectangular boxes called cells. These cells will contain your data, which may be text, numbers, formulas, or calculation results. Cells are organized in columns, which run vertically down the screen and use a letter system. This is column B, for instance. And rows, which run horizontally across the screen and use a numeric system. This is row 7, for example. Each cell is represented by a cell reference, which is essentially just a column letter and row number. For example, if we click somewhere near the center of this worksheet, we now have the cell M20 selected. This is usually referred to as the active cell. This is not only indicated by the highlighted edges of the cell, but also if you look in the top left corner of the worksheet, you will see its cell reference is noted in the little box. Here you can see it says M20. One important thing to note here is that cells are always referenced by their column letter first, then their row number, so column M and row 20. The last element of a workbook I want to mention is a cell range. This identifies a collection of several cells selected together that could mean a few cells in the same row or the same column, or it could mean several rows and columns together. This can either be done using the mouse by selecting the first cell, then dragging down or across to include other cells, or you can use Shift plus arrow keys. This range of cells is often referred to as an array, and it's most commonly used as a reference in calculations and formulas. For example, if you want to add up all the values in a column between cells D9 and D19, you would specify this cell range within a formula. Note that cell ranges are notated using a full colon between the cell references. So in this example, it would be D9 colon D19. Or to specify a few cells in the same row, it might be D9 colon H9. Or to select several rows and columns, it might be D9 colon H19. We will see this notation in use later in the course when we start looking at calculations and formulas. These cell ranges could even be a reference point to cells contained on another worksheet. This is usually referred to as a 3D reference. We can now close this workbook and we don't need to save it. In this video, we learned about some of the basic terminology of spreadsheet elements. In the next video, we will discuss how to navigate around a spreadsheet, how to use the ribbon and menus, and how to select data. Now that we have a basic understanding of the main elements that make up a worksheet, let's see how to move around a spreadsheet, get familiar with the ribbon and menus, and learn how to select data in a worksheet. To open a sample file, we click File. This opens Backstage View. Here you can create a new workbook, or open, save, or print a workbook. You can also access Excel options. Now we want to open our sample file, so we click Open and either select it from My Recent list or click Browse to find the data file we want. The first thing we should do is get acquainted with the ribbon and menus. Notice that on the ribbon at the top we have several tabs. Some of these tabs may be familiar to you with other Office products, such as the Home, Insert, and View tabs, while others might be new to you, such as Formulas, Data, and Power Pivot. To make a little more workspace for ourselves, we can hide this ribbon by double-clicking any tab, and to unhide it, we do the same. The other option is to use the shortcut key, Ctrl plus F1. The ribbon is organized into groups of buttons to make them easier to find. So on the Home tab, we have groups for font, alignment, number, styles, and so on. Some of these groups contain all the available buttons on the ribbon when viewing in full screen, such as styles and cells, but other ribbon groups have more options, which we access by clicking the little arrow icon in the bottom right corner of the group, as can be seen here on the number group, for example. The next item I want to point out is the Quick Access toolbar at the top of the screen above the ribbon. As the name suggests, this is where you can quickly access the tools you use most often. You can see we already have some tools in this toolbar, such as Save, Undo, Redo, New, and Open. But we can add other tools to the toolbar if we wish. So if we click the drop-down arrow in the toolbar and then select a tool we use a lot, such as Sort Ascending, that will be added. And we will also add the Sort Descending button. Now we need to be comfortable with moving around a worksheet. You can simply use the arrow keys to move left, right, up, and down one cell at a time. But you can also use page down and page up to move around a bit faster, which is especially useful if you have lots of rows of data. And to move even quicker up or down a large data sheet, use the vertical scroll bar. And to move left or right, use the horizontal scroll bar. Again, these can be very useful when you have a large data set. There are also some useful shortcuts you can use. Ctrl plus Home key, for example, takes you back to the start of the worksheet, that is, cell A1. Ctrl plus End takes you to the cell at the end of your data in the worksheet. Ctrl plus Down arrow takes you to the end of the column you're in, while Ctrl plus Up arrow takes you back to the top of that column. So a quick way to find out how many rows of data you have in your worksheet is to go to the first cell in your data and press Ctrl plus Down arrow to see the last row of data. So here you can see we have 160 rows. Now, how do we go back to the top again? Ctrl plus Home will do it. So far, we have seen how to navigate around our worksheet and its data. Now we need to look at how we select data. This is very important because you often need to select data to move it, copy it, or select it in a formula. The simplest selection is a single cell, usually done with a mouse or maybe a directional arrow key. The next step up is to select multiple cells together, and this can be done either with a mouse by dragging from one cell to additional adjoining cells, or you can use the Shift key with directional arrow keys. Next up is selecting a single column or row, which is done simply by selecting the letter at the top of the column or the number on the left of a row. Then we can progress to selecting multiple columns and rows by clicking the mouse button, holding it down, and dragging across more columns. Or if you are not comfortable with dragging, you can also select the column first, then hold Shift plus arrow keys to select multiple columns. The same applies to rows too. However, if you have data in non-continuous rows or columns, that is, not next to each other, you can select the first column, then use the Control key to select another unconnected column, such as columns C and F here. The largest thing you might want to select is the whole worksheet, which you can do by clicking in the top left corner of the cells. However, this selects the entire worksheet, including all the empty rows and columns. So if you only want the data in your worksheet, you can use the shortcut Ctrl+A. A word of warning when selecting data in cells, rows, and columns. There are 3 types of cross symbols that you might see when working with selected cells. The first one is the large white cross that you see when you select a cell, as can be seen here in cell A4. This is the select cross that we have been using already in this video to select cells. The second type you might see is when you hover over the bottom edge of a cell and see a thin black cross-type symbol with arrows on each point. This is the move symbol and would move the cell data to another location. The last type is the small thin black cross that is seen when you hover over the bottom right corner of a cell. This is the fill handle or copy symbol, and it fills or copies the cell data to another location. In this video, we learned how to move around a spreadsheet, become familiar with the ribbon and menus, and learned how to select data in a worksheet. In the next videos, we will discuss how to enter data, how to copy and paste data, and how to format data in a spreadsheet. Now that you have learned basic spreadsheet terminology and how to navigate your way around worksheets and select data in Excel, it's now time to start entering some data. First, we will look at some of the handy viewing features provided in Excel, and then we'll enter some data, and then we'll edit that data. When you have a lot of data in your worksheet, it can be useful to zoom in closer to a specific area of the data. The zoom slider at the bottom right corner of the worksheet allows you to do just that. You can either click on the plus and minus buttons or drag the slider to select your preferred zoom value. You also have some zoom controls in the ribbon on the View tab. Zoom lets you pick a predefined zoom level or a custom one. The 100% button zooms the worksheet back to its original size, and Zoom to Selection enables you to select an area of data and then zoom into that specific selection only. If you want to see several areas of your data at the same time while zoomed in, you can use the Split button. This splits the screen into multiple sections, and you can scroll each section separately. If you only want 2 sections, you can remove either the horizontal or the vertical split by double-clicking on it. If you have headings in your columns, like a header row, then you might want those to remain on screen while you move down the sheet. To do that, you need to use Freeze Panes. You can freeze only the top row if you wish, or if that doesn't suit, as is the case here, then you can select the row or even just a cell in the row below the row or rows you want to freeze, and then select Freeze Panes. You can do a similar thing for columns if you want to freeze them too. And you can even freeze both rows and columns at the same time. The trick here is to first select the cell that is both one row below where you want to freeze and one column to the right of where you want to freeze. In this case, that is cell C4. Now we can scroll down the worksheet and across the worksheet, and we can still see the header row and the manufacturer and model columns. Now, if you have multiple workbooks open, notice I said workbooks and not worksheets, then you can switch between them by using View, Switch Windows, or the faster method is to use the Ctrl+F6 shortcut. Now let's enter some data into our blank worksheet. The easiest way to open a new worksheet from within Excel is to click the New button in the Quick Access toolbar, or Ctrl+N if you prefer keyboard shortcuts. So let's enter some headings across the top of the worksheet. This is typically referred to as a header row. Note that if you press Enter after typing data into a cell, the next active cell is the one directly below, which is not what we want in this case. But if we press Tab after we enter data in a cell, it selects the next cell along in the row as the active cell. Now we'll enter some headings and press Tab after each entry. Notice that the text is slightly longer in some of the cells, and it either gets partly hidden by the next cell or overlaps it. If you click and hold the divider line between two columns, you can drag it left and right to resize it manually. If you want to do that automatically, you can double-click the divider line between two columns. As these are going to be headings for our columns, let's make them bold. Now let's add another column between the Parts and Accessories column. Simply select the right hand of those two columns, then right-click and choose Insert to put another column to the left of the selected column. Let's call it Servicing Sales. To tidy up our column width simultaneously, we select all the columns from A to E, then double-click any of the divider lines between columns. This automatically reduces or increases each column's width to fit the data in that column. Okay, now we have some headings. Let's enter some month data in column A. So, if we type Jan in cell A2 and press Enter, then it takes us to the cell below, which is what we want in this case. And we can type Feb in cell A3, and so on, until we get to December in A13. Now let's suppose you need to change a couple of your headings. You have several ways of editing existing data in a cell. You can either select the cell and then just start over typing, or you can select the cell and press F2 on your keyboard to put the cursor at the end of the cell and make your changes. Or you can simply double-click somewhere on the cell and put the cursor at that position in the cell and make your changes. And you can even select the cell and then click in the formula bar to edit your cell data. Now let's do the same for the Parts and Accessories column headings. In this video, we learned about some of the viewing options in Excel, and we learned how to enter and edit data in cells. In the next video, we will learn how to copy and fill data and how to format the cells and data in a worksheet. Now that we have learned about some of the handy viewing features provided in Excel and entered and edited some data, let's discuss how to move, copy, and fill data and how to format cells and data to suit our needs. The first thing we are going to discuss is how to move data. So if you select a range of cells, in this case the headings in A1 to E1, and then hover over the top or bottom edge of a selected cell, you will see the Move pointer. Then you can drag the selection to another place on the worksheet. Alternatively, if you want to copy the data instead, you do the same thing, but this time you also hold Control key as you select and drag the selection to another location, and you will see the Copy pointer. If you are not comfortable with dragging, you can also use Copy and Paste menu commands or keyboard shortcuts. If you select some data in column A and copy it to the clipboard, then you simply select the new location and paste the copied data. You can also move or copy between worksheets. So let's create a new worksheet. Then select some data from sheet 1, and this time let's use the Ctrl+C keyboard shortcut to copy it to the clipboard. Then choose the other worksheet and use the Ctrl+V shortcut to paste the data. However, notice that the column widths are not the same as the original source data, so let's undo that and try another paste option. By default, when you paste the copied data, it uses the column width settings of the destination cells. So, to paste it and retain the column widths of the source data, you choose the special option under the Paste command, called Keep Source Column Widths. As an alternative to having to enter data manually in a worksheet, you can use an Excel feature that automatically fills cells with data when it follows a sequential series or pattern. The feature is called autofill, and it can be especially useful when you need to enter lots of repetitive data into Excel, such as date information. For example, if you enter a month in a cell, even using a shortened version of the name, you can use what's called the fill handle to select down to the end of the series, and autofill will work out what the series is based on the selected data. Let's try the same thing with days of the week. If you enter Mon for Monday in a cell, then drag the fill handle to use autofill, it will determine that you want to enter the days of the week sequentially. However, if you also enter Wend for Wednesday in the next cell down and select both cells in the series, that is A16 and A17, and then drag the fill handle down, autofill determines that the sequence has changed to every other day and fills in the data series for you. It's important to select all the cells that determine the pattern when using autofill so that it can best determine what the pattern is, in this case, cells A16 and A17. A similar thing applies to numerical patterns. If you enter 5 in a cell and then use the fill handle to fill the data down the column, because the data is not the name of a day or month, for example, autofill can't determine what the pattern is yet. So in this case, it just copies the value 5 into every selected cell. However, if you enter the value 10 in B3 and then use the fill handle to fill data down the column, autofill determines that the pattern is incrementing by 5 each time, and it fills in the remainder of the data pattern for you. Now we're going to look at formatting our data, and there are essentially two distinct parts to this. First, there's formatting of the cells themselves, with a fill color and a bold border, for example, and bold text within it. And then there's formatting the data in the cells, for example, making it text format, number format, or a specific currency or accounting format. Let's open the car sales worksheet we used previously. Then select the headings in cell A3 to P3 either using the mouse, or you could use the shortcut keys Ctrl plus Shift plus right arrow. On the Home tab, click the Styles drop-down arrow and then select a style color for your cells. Then you can make the selected cells bold. Then you select the data in the manufacturer column, either using the mouse or the shortcut keys Ctrl plus Shift plus down arrow. In the Styles drop-down arrow, select another style color for the selected cells. Again, you can make the cells bold. Then you select the data in the model column again, either using the mouse or the shortcut keys Ctrl plus Shift plus down arrow. In the Styles drop-down arrow, select another style color for the selected cells. This time you can make the selected cells italic. And you can also change the font size and style. Lastly, you can select all the other cells in the data by using the mouse or the Ctrl plus Shift plus right arrow, then down arrow, and apply borders to the data cells. Now it's time to format the cell data. The sales figures in columns C and D can be formatted to display only one decimal place. Just select the data and click the Decrease Decimal button. We also have an issue with a couple of the car models. If you look in cells B129 and B130, where the model name is supposed to be displayed, you can see there are actually two dates listed instead. And if you look in the number format box, the format type is custom. This has happened because the model numbers are supposed to be the SOB 95 and the SOB 93. But when the files were imported from CSV files, these two cells must have been incorrectly determined to be date values and not just numbers. You can fix this by formatting these two cells as text and then enter the correct values of 9.5 and 9.3. The last thing we want to do is format some data as currency. If you look at the heading in column F, it says it is price in thousands of dollars, and cell F4 is using the general format. So let's change the format of this column to American currency format. We select the column, F in this case, then select More Number Formats from the drop-down list. Then we choose the Currency option and the correct currency symbol and format, and we're done. In this video, we learned how to move, copy, and fill data, and how to format cells and cell data to suit our needs. In the next video, we will look at the basics of formulas, learn how to perform simple calculations, and learn how to select ranges and copy formulas. Now that we have learned how to move, copy, and fill data, and how to format cells and data, next we will take a look at the basics of formulas, including some basic calculations, selecting ranges in formulas, and how to copy formulas. A typical formula is made of several key components. The equals sign starts the formula off and lets Excel know you are creating a formula in this cell. The next part is the function, which performs the calculation. For example, the sum function adds up the values in referenced cells or cell ranges. Then comes the reference, which is the cell or range of cells you want to include in your calculation, and these need to be enclosed in parentheses. You also have operators, which specify what type of calculation to perform. Common arithmetic operators include addition, subtraction, multiplication, and division, and these are represented by symbols: the plus symbol for addition, the minus symbol for subtraction, the asterisk for multiplication, and the forward slash for division. There are other types of operators too, namely comparison, text concatenation, and reference. You may also use constants in your formulas, which, as the name suggests, are numbers or values which you can enter directly into a formula, and which don't change. This might be a whole number, such as 5, it might be a percentage, such as 10%, or it might even be a date. So a typical formula might be equals sign, sum, open parenthesis, B5, asterisk, 20, close parenthesis, which would take the value in cell B5 and multiply it by 20. Let's start with a few basic calculations. Suppose you want to add up January and February sales of accessories. You would start by typing an equal sign, which lets Excel know you are entering a formula. Then you type in the function you wish to use, in this case, the sum function. Note the description. Next, you type an open parenthesis. Then you select your cell range, which in this case would be E2 to E3. So you could enter that as E2, E3, then a close parenthesis, and press Enter. And if you wanted to add March sales as well, then you would have to extend the cell range to include E4. So you could type E2, E3, E4 as your range, and it will work. Remember, to edit a cell, you select the cell and either edit it directly in the formula bar or press F2 or double-click the cell. However, it's very cumbersome and not very flexible to do it this way, because if you wanted to add up the entire column, then you'd have to type every cell reference, one after the other. So thankfully, there's a better way. Instead of typing each cell to include in the reference, you just put a colon between the first and last values in our range. So E2, E4 in this case. And if you wanted the whole column, then you would enter E2, E13 in your formula. But there's another way of doing it, and that's by using your mouse to select the range, so you still type equal sign, sum, then open parenthesis, but select the range with your mouse or Shift plus arrow keys, and just press Enter. Excel will add the close parenthesis for you. To total these columns up and add some tax, you'll add some headings first for subtotals and tax at 20%. Then your formula will need to multiply the value in subtotals by 20%. If you wanted to add up all the column subtotals and calculate the taxes, then you would repeat the previous process for each column. But that's very time-consuming and you don't need to, because Excel has some neat tricks to do this for you. Just select the fill handle in the bottom right corner of the cell and drag across to the other cells to copy the formula. This is called autofill. Notice how the formula is copied, but the row references change in relation to the cell's position on the worksheet. So what was E2, E13 has become B2, B13. These are known as relative references, but more on that later in the course. And you can do the same thing for the tax values in row 16. Now, you need a row for showing the totals. The calculation here is simple. The subtotal value in cell B15 added to the tax in B16. And again, you can use the fill handle to copy the formula across. If you wanted to total the sales of all products by month, you'd add a column heading. Notice how the cell style is copied to the new heading automatically. Remember, to widen a column, either drag the divider manually or double-click the divider. Then, enter the formula in cell F2 as you've done before. However, Excel has another trick up its sleeve. It's called AutoSum and is found on the Home tab in the Editing group. This is a great little shortcut for some simple common functions like sum, average, count, max, and min, but you can choose other functions too. You want sum for this particular calculation. Notice that it also has a keyboard shortcut of Alt plus equals, and then press Enter and it's done. Now you can use the fill handle to copy down the remaining values. But hold on, there is one more Excel trick to show, and it's a good one. Suppose your column of data was very long. You might have to drag the fill handle down over several pages, which isn't easy to do and can easily lead to errors when selecting large lists of data values. Rather than needing to drag down to the rest of the column, you can just double-click the fill handle and it will automatically copy the formula to all the remaining cells in that column. This one is a real time saver. Finally, let's format all these values to use the US dollar currency format. In this video, we learned about the basics of formulas, how to perform simple calculations, how to select ranges in formulas, and how to copy formulas. In the next video, we will look at how to use some of the common functions used by data analysts and discover some more advanced functions. Now that you have learned about the basics of formulas, learned how to perform some basic calculations, and how to select ranges and copy formulas, next we will have an introduction to functions, including using some common statistical functions, and then we will learn about some more advanced functions that a data analyst might also use. First, let's look at some common functions used for statistical calculations. We'll add some row headings for average, minimum, maximum, count, and median. Then, in cell B20, let's work out the average of the car sales for the year from the table above. On the Home tab in the Editing group, we click on the AutoSum drop-down list and choose Average. Now, because AutoSum tries to add up the values directly above it in the column, we need to modify the cell range here to B2 to B13. Then we can use the fill handle, as we've seen before, to copy the formula across to column E. For the minimum calculation in B21, we select min from the AutoSum list. And again, we need to modify the cell range, so this calculates the lowest value in our range. And fill across to column E, and for the maximum calculation, we select max from the list, and then modify the range. And once again, copy the formula across. This calculates the highest value in our range. In B23, we will calculate the count, which basically just means the number of values that exist in the selected range. So we select count numbers from the list. Then modify the range. For the median calculation, we can select more functions from the AutoSum list. Then select Statistical as the category and scroll down to find the median function. The median returns the exact middle of a range of selected values. Note that if you're selecting an odd number of values, it will return the figure that is the middle value in your selected range. But if you have selected an even number of values in your range, it will return the middle figure between the two middle values in your range. Once again, we need to change the cell range to B2 to B13. And we can then copy this formula across to column E. You've seen AutoSum and some of the common statistical functions in Excel, but there are another 400 plus other functions available. So let's explore just a few of those now. On the Formulas tab in the Function Library group, there are drop-down lists for several function categories. The first is a list of recently used functions, which updates automatically as you use them. Then you have functions related to financial calculations. If you hover over the name of a function, you see a short description for each one. So here we have the accrued interest function, and here is the interest rate function. The logical list has Boolean operator functions such as and, if, and or. There are several functions related to text, such as concat, which is an updated version of a previous function called concatenate, which is still supported, by the way, for backwards compatibility, find, and search. There are also several functions related to dates and times, such as net workdays, weekday, and weeknum. In the lookup and reference list, there are functions such as areas, HLOOKUP, sort by, and VLOOKUP. In the math and trig list, you'll find lots of useful mathematical functions, such as power, SUMIF, and SUMPRODUCT, alongside many functions for trigonometric purposes, such as cosine, sine, and tangent. There is also a more functions list, which provides several more function categories, such as statistical, engineering, and information. In the statistical list, you'll find functions such as average, count, max, median, and min. We saw some of these used earlier in this video. If you're struggling to find the function you want in these lists, you can also search for a function. Just click the Insert Function button on the Formulas tab, and then either browse the category lists available or choose All and look down the alphabetical list for the function you want. Alternatively, type the name of a function you want and click Go to search for it. Then select the one you want from the returned search. In this video, we learned about the basics of functions, how to use some of the more common functions that a data analyst might employ, and looked at some of the more advanced functions available in Excel. In the next video, we will look at referencing data in formulas, specifically differentiating between relative and absolute references, and error handling in formulas. Now that you've had an introduction to functions, seen the use of some common statistical functions, and learned about some of the more advanced functions that a data analyst might use, in this video, we'll look at the difference between relative, absolute, and mixed references in formulas, as well as how to use them, and we'll learn about formula errors in Excel. It's important to understand the difference between relative and absolute references when creating your formulas. By default, in Excel, cell references are always relative references. The term relative is the key here because it means that when you reference a cell, you are in fact referencing the cell's position in relation to the cell that the formula is in. That is why, when we have been copying formulas from one cell to another so far in this course, using either copy and paste or the fill handle, we haven't needed to modify the cell references because Excel assumes you are using relative references. When the formulas are copied, the cell references are changed to match the relative positions of the cells that are being copied to. So now we know that relative references are the default in Excel, but how do we make it so that the cell references don't change when we copy them? For that, you need to use absolute references. In contrast to relative references, absolute references to cells stay the same when you copy a formula containing such references. Lastly, there may also be some instances where you only want one of the cell reference identifiers to be absolute and the other one to be relative. For example, you might want the row identifier to be absolute, but the column identifier to be relative, or vice versa. These are called mixed references, and an example of this would be $A $1 plus $A3, where $A1 has a relative column and an absolute row, or $A3 has an absolute column and a relative row. In contrast to relative and absolute references, when you copy a formula containing mixed cell references, any relative cell references will change, whereas any absolute cell references will stay the same in the copied formula. First, let's look at an example of using relative references in a formula. For example, if we enter the formula equals A1 plus A3 in cell 4, note the blue and red highlighted cells in A1 and A3. These denote the cells being relatively referenced in the formula. If we copy the formula to the cell directly below using the fill handle, we can see that the result changes. And if we look at the copied formula, you can see that the blue and red cell references have changed relative to their position on the worksheet. The formula has been changed to equals A2 plus A4 in the copied formula. That is, each cell reference has moved one cell down. And if we copy and paste the formula to C7, you can see that the result also changes. And again, we can see that the blue and red cell references in the copied formula have changed. Now, let's look at an example of how to use absolute references in a formula. All you need to do to make a cell reference absolute is put a $ in front of the column and/or row identifiers in the formula. For example, if we enter the formula equals $A, $1, $A, $3 in cell E4, note the blue and red highlighted cells in A1 and A3. These denote the cells being absolutely referenced in the formula. When we copy the formula using the fill handle, you can see that the result stays the same this time. And if we look at the copied formula, you can see that the blue and red cell references haven't changed. The formula is still $A, $1 plus $A, $3 in the copied formula. That is, the cell references haven't changed. Similarly, if we then copy and paste the formula to E7, you can again see that the result stays the same this time. And we can see that the blue and red cell references haven't changed. The formula is still $A, $1 plus $A, $3 in the copied formula. That is, the cell references haven't changed. Lastly, we'll look at an example of how to use mixed references in a formula. So if we enter the formula equals A, $1 plus $A3 in cell G4, note the blue and red highlighted cells in A1 and A3. These denote the cells being referenced in the formula. If we copy the formula to the cell below using the fill handle, you can see that the result changes, but it's a different result from the previous examples. And if we look at the copied formula, you can see that the first blue cell reference has stayed the same, but the second red cell reference has changed. If we copy and paste the formula to G7, you can see that the same thing happens. The result changes. And again, we can see that the first blue cell reference has stayed the same in the copied formula, while only the red cell reference has changed. Now we'll have a quick introduction to dealing with formula errors in Excel. Because of the complexity of writing formulas, especially the more complicated ones, there are bound to be occasions when you make a mistake in the syntax or in the data selection, which will lead to a formula error. Errors are typically denoted by displaying, in the cell that is supposed to be displaying the result, one of the error codes in this list. When you see multiple hash symbols in a cell, it's not really an error. It just means the column either isn't wide enough to display the whole word or value, or it contains a negative date or time value. So if we type Control plus semicolon, then space, then Control plus Shift plus semicolon, it enters today's date and the current time. But the cell is too narrow to display it, so what we see is multiple hash symbols. If we adjust the column width, we can now see the cell contents. So as I said, this really shouldn't be considered as an error. However, if we enter the formula seen in cell I7, when we press enter, we see a hash name error. This error was caused by trying to use an X as a multiplication operator, when in fact it should be an asterisk. Note the small green triangle in the top left corner of the cell. Also, note that when you select the cell, an exclamation mark appears, providing you with a hint about what caused the error. In this case, it says the formula contains unrecognized text. When you click the drop-down arrow next to the exclamation mark for an error, you see several options. The first line also gives you a clue on the nature of the error. This one says invalid name error. So it was probably a mistyped cell reference, value, or function name. If you click Help on this error, a help pane opens with specific information related to this error. If you click Show Calculation Steps, a dialog box opens displaying the current syntax with the error underlined, and you can try to evaluate the error. If you are certain the error is incorrect, you can choose Ignore Error. And if you want to edit the formula, click Edit in Formula Bar, and the cursor will be focused in the formula bar so that you can try and correct the formula error. If you click Error Checking Options, the Excel Options dialog box is opened at the section related to error checking rules, and you can modify these options to suit your needs. Each of the errors you make, which generate one of the error codes listed at the start of this video, will have a different reason and a different solution. For more information on each of these errors and typical solutions, visit the link provided. In this video, we learned about referencing data in formulas, specifically differentiating between relative, absolute, and mixed references, and how to use them. And we learned about formula errors in Excel. Now that you have learned about the importance of data quality, in this video you will learn how to import data from a text file using the Text Import Wizard, learn how to adjust column widths, and learn how to add and remove columns and rows. As you know, by default, Excel works with .xlsx or .xls files and opens them as workbooks. But Excel can also use data that is in other formats, such as plain text or data that has been comma separated and tab separated. Sometimes these source files will be saved with a .txt extension and referred to as text files, but others might be saved with a .csv file extension and are typically referred to as CSV files. Here in Notepad, I have opened a text file that contains data about car sales, and it uses comma-separated values, or CSVs, to separate each bit of data in a record. Notice that the top line holds headings, such as manufacturer, model, engine size, and so on, and each one is separated by a comma. We want these to become our headers when we import the file into Excel. The line below these headings is the first line of real data, and again, you can see that each piece of data is also separated by a comma. There are 16 headings, and there are also 16 pieces of data on each of the lines below the headings. If we scroll to the bottom, we can see that last data record is for the Volvo S80. Now, to open the file in Excel, we choose File, Open, and then either select the file from the recently used list or click Browse to find the file we want to import. When we open the file, the Text Import Wizard launches automatically, and it will start to try and determine what your file is. Note that it has been detected as being a delimited file, that is, one that has its data fields separated by a character such as a comma or a tab. As we want the headings to become headers in Excel, we need to ensure that we select the option My Data Has Headers. We can see a mini preview of the data in the preview box below. Then we click Next to proceed in the wizard. In step 2 of the wizard, we need to select our delimiter, that is, which character is separating our pieces of data, so we select comma and deselect any others. Note the data preview now starts to show us what the imported data will look like. You can scroll down and across this preview window to ensure that the data is going to look as you want and expect. It all looks okay, so we'll continue with the wizard. In step 3 of the wizard, we can set the data format for each column. For example, you might want to change a column to text or date format. In this case, we can just accept the default general format and finish the import wizard. In Excel, we can see that the headings in the text file have been imported as a header row. But also notice that some of the columns are not showing all the data. Some of the headings are not showing in full, and some of the data is not shown either. All you can see are a number of hashes in the cells. This is because the column widths are too narrow in some cases. If you remember, you can manually adjust a column's width by dragging the divider across, but to change them all in one go, we select all the columns first, then double-click one of the selected column dividers. We can also do a similar thing with rows by dragging them to make them bigger or smaller, or double-clicking a row divider to auto-size it. There are some columns that we have decided we don't really need, namely vehicle type and latest launch. So let's remove those. This can either be done using the Delete drop-down menu in the Cells group on the Home tab and select Delete Sheet Columns, or by selecting and right-clicking a column and deleting it that way. To add another column, you simply select the column to the right of where you want your new column to be. Then right-click the column and choose Insert. And let's give the header a name, such as Year. To delete a row you don't need, select the row, right-click it, and choose Delete. And to add a row, select the row below the place you want to add your new row, right-click the row, and choose Insert. If you want to save the file as an Excel file, you can either choose File, Save As, or you can click Save As in the yellow tooltip that appeared at the top of the worksheet when we imported the file. Then you would choose Excel Workbook or .xlsx in the Save As type box. In this video, we learned how to import data using the Text Import Wizard. We learned how to adjust column widths, and we learned how to add and remove columns and rows. In the next video, we will discuss the importance of data privacy, including sensitive information and personally identifiable data. Now that we have learned about the importance of data quality and data privacy, in this video we will learn how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated data. It's very common when collecting or importing data, whether through manual or automated processes, to get errors and inconsistencies in your data. This can be as simple as spelling mistakes, extra white space, or the wrong case used in text, to empty rows or missing values in your data, to inaccurate or duplicated data. Having these errors and inconsistencies in your data can lead to issues with formulas not working, with unsuccessful sorting and filtering operations, and therefore inadequately visualized and presented data findings. These data errors and inconsistencies require you to carry out some form of data cleaning routine to improve the quality and usability of the data. Let's start off with one of the easier of those tasks, which is spell checking. In Excel, this works in pretty much the same way as you may have already encountered in applications such as Microsoft Word or other common word processing applications. I have some data here relating to the sales of toy vehicles, and the first thing we need to do is select what data we wish to check for spelling. In this case, we will try column K, which contains the product line data. Then we click Spelling, which is on the Review tab. Well, that seems to be okay. So let's try the country information in column T. So we do have an error here where a country name has been misspelt, or more likely, mistyped. We just click Change if we are happy with the spelling suggestion, or we could choose another suggestion from the list, or even ignore this error if we know the data is correct, but in this case, we will change it. Here's another typo for a country name, and here's one more. So that seems to be all the errors in this column. Let's try the final column now, which is the DL size in column X. Here is a misspelling of the word small, and another for medium, and that seems to be all for this column. The next inconsistency we will look for is empty rows. Empty rows in your data can cause lots of issues relating to moving around your data, working with formulas, and sorting and filtering. Therefore, it's very important to remove them from your data. If you remember from an earlier lesson, when we click Control plus down arrow, it should take us to the end of that column of data. But notice if we do that in this data set, the cursor keeps stopping when we get to an empty row, meaning that the data set is essentially being split into multiple sections, separated by these empty rows. That's not good, so let's resolve that now. We have a couple of options. One option is to just manually scroll down the sheet looking for empty rows and deleting each one, which is easy enough and fine to do if you only have a small amount of data. But imagine if you were dealing with hundreds or thousands or even tens of thousands of rows. That would be a very laborious and time-consuming process. There is a much better way, which involves selecting all our data first, either using the mouse or the Control plus Shift plus End keyboard shortcut. Then we select the filter icon on the Data tab. We can now see that each column has a filter icon next to the column header. If we then select the customer name column filter in column M, then uncheck Select All, then scroll down to the bottom of the list, we can check the item called Blanks, and then click OK. This will now show only the empty rows at the top of our sheet. This can be quite hard to see, but if you look in the row numbers, you can see that rows 28, 29, 65, 73, 74, 75, and 117 are listed at the top and are highlighted in blue text. We can now select these rows either using the mouse or going to the first cell in the first data row, which is A28, and then using the Control plus Shift plus End keyboard shortcut. Then delete the offending empty rows. We then need to clear the filter and turn it off so we can view our data again. Now, if we go back to the first row in the top of the data sheet and try the Control plus Down shortcut again to go to the end of the data column, it will work. The next inconsistency we'll look for is duplicated rows of data. It's quite common for duplicate data rows to exist in your imported data, caused either by human input error or an error in the import process. There are two ways of doing this in Excel. The first way includes reviewing the data you plan to remove first before deleting it to ensure you are deleting the right data. This is our preferred method as it provides an additional level of data security. The second method, which we will also show you, is simpler, as you don't review the data to be removed first, but it lacks the security of the first method. It's important to select a column of data that you would not expect to have duplicate values in. For example, if we consider the price each column, which is C, we would expect lots of these values to be repeated because the unit price of some products is the same. So this is a bad example of a column to use to find duplicates. Instead, let's use the sales column in column E because it is far less likely that these values will be duplicated in the normal process of things, as they are the total sales for each order. So we select the column and choose Conditional Formatting, then highlight Cells Rules, and then Duplicate Values. When we click OK and scroll down the sheet, we can see that only a few values have been identified as being duplicates. There seem to be duplicate values in rows 36 to 40 and in rows 74 to 78. Let's zoom out so we can see both duplicate sections together. It seems like these are in fact exact duplicate entries and are likely to be an input error. Let's delete the second section of duplicate rows as they are out of sequence, as they relate to motorcycle sales and are in the ships section of the sheet. So that was the first and recommended method of removing duplicate rows of data, which previews the data to be removed first. Now, let's try the second, simpler but less secure method. Let's go back to 100% zoom and go back to the top of the worksheet. This time, we select the whole data sheet, and on the Data tab, we use the Remove Duplicates button. We then unselect all the columns, then only select the Sales column, and the duplicate rows are deleted. The last cleaning process we'll look at in this video is using the Find and Replace feature to repair some misspelt surnames in the Customer Contacts column. Find and Replace tools are under Find and Select on the home page in Excel. If you have used other Office products such as Word, it should be familiar to you already. We've had an email from a Swedish customer informing us that we have her surname spelled incorrectly on her order sheets. So we type the misspelled surname into the Find What box and click Find Next. Then click it again to see there are multiple incorrect entries. If we click Find all instances are listed, and we can open the Replace tab to enter a name to replace the incorrect spellings. Her surname should be Larson with a double S, so we'll replace all instances with that corrected spelling. That looks better, and we are finished. In this video, we learned how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated data. In the next video, we will look at changing the case of text, fixing date formatting errors, and trimming whitespace from data. Now that we've learned how to deal with inaccurate data, how to remove empty rows, and how to remove duplicated rows, in this video we'll look at changing the case of text, fixing date formatting errors, and trimming whitespace from data. When you collect or receive data from various sources, it's quite common to find that your data contains text in mixed case, that is, some in uppercase, some in lowercase, and some in capitalized proper case, also known as sentence case. Some of this may be intentional, but often it's not. Excel doesn't have a change case button like there is in Microsoft Word, so you need to use other methods to perform this data cleaning task. Those methods are functions, namely the upper, lower, and proper functions. You can use these functions to help you change the case of text in your data. You can see that the header row here is using all uppercase characters. So if you want to change that to use proper case, then you need to add another row to put the function in. This is referred to as a helper row. The proper function is simple to use. Just type equals, then proper, then open parenthesis, then the cell reference, in this case A1, then close parenthesis, and press enter. Here you can see that the result in A2 is in proper case. Now you can try and drag the formula right across to column X by using the fill handle on A2, but this can be tricky when you have a lot of columns, so let's try another way. Instead of dragging, you can use Shift plus right arrow to select the columns across to X first. Then press F2 to bring the cursor into focus in cell A2. Then you hold down the Control key while you press Enter, and it fills across for you. You might think that you could now remove the original row, but look at what happens when you do. You get a ref error because the formula is referencing an invalid reference, and the header row cells now contain just the failed formula rather than the actual header text. So you need to undo that, and instead, you copy the contents of the helper row to row 1. But when you paste, you need to choose the Paste Values option. Now the header row cells just contain header text, and you can remove the helper row in row 2. Now let's use the upper function to change text from proper case to uppercase. Insert a column to the right of the column you want to change. This will be a helper column. Then you type the formula containing the upper function in the first data cell in this new helper column. Again, it's a simple formula. You type equals, then upper, then open parenthesis, then the cell reference, in this case T2, and then close the parenthesis and press enter. You can see the result in the country name in uppercase, and you can then copy that formula down the rest of the column by double-clicking the fill handle cross symbol. As before, you then copy and paste the contents of the helper column to the original column, but use the Paste Values option. Now you can delete the helper column. Next, we'll use the lower function to change text from proper case to lowercase. As before, you insert a column to the right of the column you want to change. This will be another helper column. Then you type the formula containing the lower function in the first data cell in the helper column. Once again, it's a very simple formula. You type equals, then lower, then open parenthesis, then the cell reference, in this case K2, and then close parenthesis and press enter. You can now see the result is the product line data in lowercase, and you can now copy the formula down to the rest of the column by double-clicking the fill handle once more. As before, you then copy and paste the contents of the helper column to the original column by ensuring you use the Paste Values option. Now you can delete the helper column. It's quite common to receive data that has a mixture of date formats, or that uses a date format that isn't suitable for your region. Now, let's look at how to change the format of some dates. You can see that this date format is currently using a 2-digit day, a 2-digit month, and a 4-digit year value. When you open the number format dialog box, you can see in the locale box that this is an English or United Kingdom date format. You want to use a US date format, so you first change the locale to English, United States. In this list, you can see there are several date options to choose from. Let's choose one that uses the full month name, then a 2-digit day and a 4-digit year value. You could then copy this formula to the rest of the date cells. However, if you want to format these dates using your own custom format, you can do that too. In the number format list, you select Custom and then choose an existing format that is similar to what you want, and simply modify it to create a new custom format. Here we'll have the day, then 3-letter month, then 4-digit year. To apply that new custom date format to the rest of the column, you could either use the Format Painter tool, or you can select the rest of the column and choose the new column format from the custom list in the number format dialog box. You might find that your data has some white space, that is, unwanted spaces in your data. Here you can see that we have some spaces at the start, some spaces at the end, and some unwanted double spaces in the middle of our data. We'll first have a look at what you can do to clean up these unwanted spaces in your data by using the Find and Replace feature in Excel. So you first select all the data, then on the Home tab, you click Find and Select, then Replace. To get rid of double spaces, you enter a double space in the Find What box and a single space in the Replace With box. Then you click Find Next and choose Replace for each item you want to change. You could click Replace All to do all the fixes in one go, but unless you are absolutely sure of the changes, it's better practice to check and replace each one in sequence in case there are some valid reasons for these extra spaces. If you have a very large data set, you might also choose Replace All to save you a lot of time. So using the Find and Replace feature got rid of most of those unwanted white spaces, but not all of them. We removed double spaces using that feature, but we also have some single spaces left at the start and end of some of the cells. You can't use Find and Replace to remove single spaces. Otherwise, you would lose all spaces in your data, including standard spaces between words, which you don't want to remove. But there is another tool you can use to clear spaces from cells, and that's the Trim function. To use the Trim function, you once again insert a helper column. The Trim function is simple to use. Just type equals, then trim, then open parenthesis, then the cell reference, in this case, M2, then close parenthesis, and press Enter. You can then double-click the fill handle symbol to copy this formula down to the remainder of the column. Now, you need to copy the contents of the new column N to column M, and remember once again to paste using the Paste Values option. You can now see that those erroneous spaces have been removed, or more accurately speaking, have been trimmed. And lastly, you can remove the helper column. In this video, we learned how to change the case of text, how to change date formatting, and how to trim white space from data. In the next video, we will discuss how to use the Flash Fill and Text to Columns features in Excel to help clean data.